These are the notes for Unit 2, Lesson 3, Models and Simulations. There are 2 learning targets for this lesson. First, I can explain why scientists use models and simulations. And second, I can describe the 3 types of models and I know when to use them. And those types of models are physical models, conceptual models, and mathematical models. There are 5 vocab words in this lesson. A model is a pattern, plan, representation, or description used to show the way an object or system works. A simulation is a method used to study and analyze a system. A physical model is a 3-dimensional representation of an object, such as a toy car. A mathematical model is an equation that shows the way a system or a process works. That could be an equation, it could be a graph, it could be a computer simulation. And then a conceptual model is a written or a visual explanation for how a system works. One example would be the water cycle, and we'll look at that later in this lesson. In class, we read 2 pages from the lesson. You can find these in the student edition on Think Central. These 2 pages introduce what models and simulations are and how they're used by scientists, and those are found on pages 94 and 95 if you'd like to check those out in the student edition. Then we talked about models. Models are helpful because they help us to study events that are too dangerous, too fast, or too slow. They can be used to test new ideas, to represent complex systems, to show faraway objects and concepts, to show things like an atom or a cell that are too small to study closely, things that happen too quickly for the human eye and brain to really process them, maybe things that are too big. For example, we can study the solar system with a smaller model of the real thing. So as you can see, there are lots of ways that models are helpful to us and lots of times that they would be appropriate to use in science. Models are limited though because they can never completely replace the real thing. They might not have all of the parts that the real thing has, or they might not give all of the information. Some examples of that would be things like a matchbox car. A matchbox car can show us a lot about a car, but obviously it's missing parts that a real car has. Can you think of some parts that a matchbox car doesn't have that a real car has? Sure, the engine, seat belts, anything that a human would need in the car, basically. Then there are 3 types of models that we use in science. The first is a physical model. That's easy to spot because it's 3-dimensional. It's something you can hold in your hands. The physical model might be bigger than the real thing, like an atom model, might be smaller than the real thing, like a skeleton, or it might be the same size as the real thing, like a model of an organ that someone who's practicing to be a surgeon would practice on. A mathematical model is easy to spot because it contains numbers. A mathematical model represents the way that a system or a process works. And like I said, it's made of numbers. It could include equations or data. Some examples are a computer simulation, an equation like this one, y equals mx plus b, or a graph. Here's an example of a mathematical model. This graph shows a student's favorite juices. Simulations like a weather map, when you watch the news, would also be included as mathematical models. They take a lot of data and they put it into a visual representation. A conceptual model is a little bit harder to understand. Conceptual models use words and pictures to show a system, and they're based on ideas. A concept is an idea. One example is this diagram of the water cycle. So it uses pictures and arrows. The arrows are always a big indicator that you're looking at a conceptual model. This diagram of the water cycle uses arrows and pictures to show us how the water cycle works. It evaporates from things, water evaporates from things like rivers and lakes, goes up into the atmosphere, and then it precipitates, it falls to the earth again in the form of rain or snow. So you can see arrows pointing up to show the water moves up, arrows pointing down to show how the water comes back down to earth. And those are the notes for Unit 2, Lesson 3 on models and simulations. You can also find the digital lesson on Think Central. You watch that in class, and that's a good way to review this information.